versus finite, which actually has an end value. Okay, so here's an example. If you save $128 one month, and half of that the next month, and half of that the next month, how much will you have saved for 10 months? So we're going to use the sum formula because that's how much we're saving each time, right? So in 10 months, how much you will have saved is S10, yes? What's my common ratio? Half. So it's going to be the first term, which is 128, and then 1 subtract a half to the power 10. Make sure you put the half in brackets, because if you just write a half to the power 10, it only means the numerator is to the power 10. Just like when you have a negative sign, you got to do brackets as well. And then 1 minus a half. So I'll grab my calculator and we will do this calculation. Did you get 255.75? So you saved $255.75. This is a different problem than when I deposit a cent and then the next day is 2 cents and 4 cents. I'm doubling each time, right? How about 20 months? So 128, 1 minus 1/2 in brackets to the power 20, divided by 1 minus a half. Let's see what we get this time. So some people are saying, shouldn't it be double that? No. Yes, you're saving less and less each month, right? And at some point, you stop saving.
Never stop.
So what did you get? But the 9, doesn't the 9 round? But isn't there another 99 after it? Yeah. So if we're talking about money, it's $256. Yeah, like I'll write down exactly what it is. 255.99975. Like pennies only go up to there, right? So okay, so 10 months later, do you guys see the difference between the two? It was only a quarter more. Like 25 cents more. What do you mean $1 more? It goes from $255.75 to $256. It's only 25 cents more. Okay, notice that the more terms we add, the closer 1 minus r to the power n gets to 0. Actually, I shouldn't say it gets to 0. The r to the power n is getting to 0, so then 1 minus 0 is getting to 1. We're not actually changing much. As n, does everybody understand that? The bigger the power that 1/2 is, at some point is basically nothing. This is basically nothing, so 1 minus 0, basically nothing, is still 1. So you're not changing much at that point. So as n gets larger and larger, the sum approaches 256. And in fact, if I went to 100 months, I would still get $256. Try it on your calculator. Do 100 months. And what do you get when you do 100 months? Try 100 months instead of 20 months. So it's to the power 100. You get 256 exactly. If you do 1,000, you'll get 256. So what happens is, because you keep on having the amount you're saving, at some point you're not having much anymore and you're not contributing more to that sum. So we say the series, or what we added up to be, approximates 256. Does every sum of every geometric series approach some limit? So now we're talking about a lot of terminology that's in calculus where things go on forever. So for instance, if I saved $128 one month and saved double that amount the next month and double that, how much will you save after 10 months? So let's do this one. So we're doing S10 again, but what's the difference in this question? It's getting doubled. So it's 1 minus 2 to the power 10 divided by 1 minus 2. So if you punch that into your calculator, what do you get? Huh? No, 130,944. Is that what you got? Okay, try it. Yep. Did somebody get that? Okay, thank you. Now let's try S20. So how much would you have saved up there? Yeah, 134,217,600 this time. So is there a way that we could actually figure out a finite sum in this case? Does everybody know the difference between finite and infinite? It actually ends. So this doesn't end, and neither did the other one, but in this case we knew eventually it would add up to 256. In this case, it just keeps growing and growing and growing and growing. So I'll show you the difference between the two graphically. Changing anywhere. Whereas this one over here, you're starting at 128, and because it's doubling each time, it's actually going like this. And this is actually going to infinity quite fast. Well, not that infinity is an end result, but this, because you're not adding or attributing too much afterwards, it levels off and it approximates a certain sum. So what's the difference between the two questions? One has what? Yeah, so what makes one get a sum and not a sum? It's the same question. One was halving, the other one was doubling. So what's the difference? It has to do with the ratio. So can anybody think they could guess what makes a finite sum out of an infinite? It has to be less than 1, yeah. Has to be less than 1. It has to be a fraction between 0 and 1. Okay. So, as n gets larger, the sum, Sn, gets larger. The sum does not approach a finite limit. It approaches infinity. Infinity. And we know that infinity is the symbol, it looks like a sideways 8, yes? We say that this series diverges. It goes diverge. If you think about divergent thoughts, divergent, yeah, so what was that all about, the movie?
It was different.
Okay, so if this is the absolute value of the common ratio, meaning you could have a ratio of -1/2 or -3/4. So if the absolute value is less than 1, in other words, if a ratio is a fraction or decimal between -1 and 1, then n gets bigger and bigger. R to the power n approaches 0, and this series has a answer to the sum. Has an answer? Okay, so do you understand when you actually get, if you add up a whole bunch of numbers forever and ever and ever, when you actually get an answer and when you would say infinity is the answer, because you can actually add it up? The ratio has to be less than 1. The common ratio, the absolute value, has to be less than 1. Okay, so here's the first term. The common ratio is 3. Could I add up this sequence forever and get a sum? No. So that means it is divergent, and the sum to infinity is infinity. You can't actually do that forever. Okay, so what happens if your term is 1/2 and your common ratio is 5? That means you're multiplying it by 5 each time. Could you actually add it up forever and get a sum? No. Diverges. So s to infinity is infinity. Diverges, divergent is just a form of the same word, right? Diverges, meaning it goes like this. It goes, whoops, it goes like this. Converges means it's going to taper off, right? It's going to converge to a certain amount. So how about this one? This is convergent. Convergent because the ratio is less than 1. Then it's not really doing anything. You're just adding the same number onto it again, right? So that's why it's less than 1, not less than or equal to 1. Yes. Okay, so the formula for sum to infinity. So essentially, you cannot use this formula unless the ratio, the absolute value of the ratio is less than 1. It won't work. You'll get a number and an answer, and you'll think you have an answer, but it doesn't make sense, because if you're adding something that's getting bigger and bigger and bigger again, there's no way you could actually get a sum out of it. Okay, so the first term is 3, and then we're subtracting 1/3 to 1. What's 3? Sorry, what's 1 subtract 1/3? 2/3? Yes? And then 3 divided by 2/3? We get 9/2. Yes? How do I get 9/2? This is 3/1 times, you flip 2/3 to be 3/2, and you get 9/2. Okay, so note, we can only use this formula when there is a limit to the sum. Oh, actually, I guess that's what I probably wanted up there, was a limit. You can leave it as answer. A limit to its sum. Okay. Find the limit of the sum of the infinite number of terms of this series. Okay, so does everybody see this sum goes on forever? 5 plus 1 plus 1/5 plus 1/25. What would be the next term? 1/125. You could keep on adding stuff forever, but do you see, eventually you're going to be adding a minimal amount to it. So that means we can actually figure out a sum. So first thing we have to figure out is, if term 1 is 5, what is my common ratio? 1/5. We're dividing by 5 or multiplying by 1/5 each time. So if I want to find the sum to infinity, it's going to be 5 divided by 1 minus 1/5. It's the easiest formula of all the formulas we have. You just have to know the concept of that the ratio has to be between -1 and 1. So this is 5 divided by 4/5, which is 5 times 5/4, which is 25/4. The limit would be 25/4, yeah. In this case, the limit exists, right? Okay, so the next one is worded this way. Find the sum to infinity for the sequence 1 minus 3/4 9/16, 25/4. Okay, so what is the common ratio here? -3/4. Does everybody see you're multiplying by -3/4 each time? And if you didn't know, just take the second term and divide by the first term, and dividing by 1 is pretty easy to see. It's -3/4. Okay, so can I use the sum to infinity formula if the ratio is -3/4? Yes. It's between -1 and 1. Exactly what I want. So the sum to infinity is the first term, which is 1, divided by 1 minus the ratio. So this is 1 minus -3/4. So that's actually 1 plus 3/4. If you take 1 and add 3/4 to it, what do you get? 7/4. And if you divide 7/4 by 1, 1 divided by 7/4, what do we get? 4/7. 1 plus 3/4 is 1 3/4, which is 7/4. Yes? Or you can remember that 1 is 4/4 plus 3/4, and you get 7/4. Either way, you get 7/4, right? 7/4, and then you have to divide 1 divided by 7/4 and get 4/7. Okay, next one. Find the sum of the following geometric sequences. Do you guys want to try the next one?
Sure.
Okay, try A and B. Try A. Did everybody get this is infinity? So first off, you have to figure out that the common ratio is 36 divided by 27 or 48 divided by 36. Either way, you get 4/3. Okay? Just divide it. You'll get 4/3 or 1.3333 repeating. That means the ratio is bigger than 1. You cannot calculate using that formula because it goes on forever and gets bigger and bigger and bigger. Okay, what does this mean when it's in sigma notation? The top value is infinity. That means you're plugging in terms forever and ever. So the first thing is we need to find the first term. What's the first term? 3 times 2/3 to the power 0. Does everybody see? It's 3 times 2/3 to the power 0, which is just 3. Yes? Huh? If you plug 1 in, 1 minus 1 is 0. 2/3 to the power 0 is 1. 1 times 3 is 3. Okay? So, do I need to find the second term, or can you tell what the common ratio is going to be? Yeah, the common ratio is 2/3. But if you didn't know, you could plug in the next term and find that the next term is 3 times 2/3 to the power 1, which is 2. Anyways, the common ratio is 2/3. So, can we use the formula? Yes. So that means this is equal to 3 divided by 1 minus 2/3, which is 3 divided by 1/3, which hopefully you know the answer is, what's 3 divided by 1/3? 9. Third problems. The following diagram, the largest circle, A1B, is 8 centimeters. Obviously my radius in my picture is off. Is yours in the right spot? Not even close. This should be A1. This should be A2. Sorry about that. This should be A3, and so on. And this is B. B would be right here. It's the outside there. Well, not the outside, but where they all intersect there. Yes, the radii are being halved each time. So the radii, or the ratio, I'm talking about circumferences here, though. That's the problem. So is the common ratio going to be halved here? Well, first off, do you know what the formula for circumference of a circle is? Radius times the diameter, or 2 pi r. And because we're given the radius, we're going to use 2 pi r. So the first term, can anybody tell me what the first term would be? The radius was 8 centimeters. So what would the first term be? Well, 2 times pi times 8. So what do we get? 16 pi? Yes? Yes? Okay, the second term is, the radius is now halved. So 2 times pi times 4. And we get 8 pi. So now if you divide those two, what do we get for the common ratio? We get 8 pi divided by 16 pi, and in fact, we do get the common ratio to be a half. The reason why I showed it to you this way, and you said, well, I knew it was a half to begin with, the next question for area, it's not the case. So watch it. You should still find, yes, you should still find those. Okay, so if the first term is 16 pi, my common ratio is a half. Can I find the sum of all the circumferences? For sure I can. The sum infinity is the first term, which is 16 pi divided by 1 minus a half. What's 1 subtract a half? A half. What's 16 pi divided by a half? 32 pi. And that would be centimeters, by the way, because I would lose a half mark if I don't have my units. Huh? No, we use exact values here. Because otherwise we're rounding. Okay, who remembers the formula for area of a circle? Area of a circle. It's not the radius times pi. Holy man. How about pi r squared? This is just something you know. I don't know. Okay. What would term 1 be if the radius was still 8? Pi times 8 squared. So what would I get for term 1? 64 pi. What would I get for term 2? Remember, the radius is half, so it's going to be now 4 squared. So what do I get? 16 pi. So what's happening each time? It's being fourth. Not halved, it's being fourth. Why is that the case? Because your radius that's getting halved is actually getting squared, so that's why it's getting quartered each time. Okay, can we find the sum of all the areas now? Yes. So the sum to infinity is the first term, which is 64 pi, divided by 1 subtract 1/4. What's 1 subtract a quarter? 3/4. And 64 divided by 3/4. If you're using your calculator, don't put the pi in your calculator. Just get your answer and put the pi back in. But you should get 256 pi over 3. And what's our units here? Centimeters squared. Because it's area, right? Because it's area.